Hello everyone, and this is a 14 mark normal distribution question. So it says a health center claims that the time the doctor spends with a patient can be modeled by a normal distribution with a mean of 10 minutes and a standard deviation of 4 minutes. Using this model, find the probability that the time spent with a randomly selected patient is more than 15 minutes. Okay, so we have got, let's first of all, let's say let x, so we've got to define our test statistic, let x equal the time spent with a patient. Time spent with a patient. And x is going to be normally distributed with a mean of 10 minutes and a standard deviation of 4 minutes. So that's our distribution. And we've got to, for part A, find the probability that a randomly selected patient is more than 15 minutes. So that is the probability of x is greater than 15. So when we put that into our calculator, we're going to put a lower value of 15 and a really big number as an upper value. And we get 0.105649. So that's our answer that we get. So to three significant figures, 0.10 6 to three significant figures. Now, it says some patients complain that the mean time that the doctor spends with a patient is more than 10 minutes. The receptionist takes a random sample of 20 patients and finds that the mean time that the doctor spends with patients is 11.5 minutes. Stating your hypothesis clearly and using a 5% level of significance, test whether or not there is evidence to support the patient's complaint. So first of all, we need to define our null and alternative hypothesis. So our null hypothesis is that the mean is 10, and our alternative hypothesis is that the mean is in fact greater than 10, because the patients are complaining that some doctors are spending too long with patients. We've got a sample from a normal distribution, and when we have a sample from a normal distribution, the distribution is given by mu and sigma squared over n. So in this case, our distribution for our sample is going to be that our mean is 10, our standard deviation is 4, and our sample of patients is 20. Okay, that's fine. Now, the thing I would say about that is I could actually write that. Well, just remember that when you put that in your calculator, you need to square root that. That's the important thing. And we're finding out that the doctor actually spends 11.5 minutes. So we're going to put that into our distribution, see what we get. Now, remembering that this is sigma squared and that when we enter this into the calculator, what we would actually enter into the calculator. So what I'm saying is sigma squared is the 4 squared over 20. But when you put that into your calculator, you only need sigma. So you need the square root of that whole thing, the square root of 4 squared over 20. So what you're going to put into your calculator is going to be 4 over root 20. So don't forget that. So a common mistake that students make, not forgetting to square root the standard deviation. So we do need to square root that when we put it in the calculator. Okay, so 4 over root 20 is what you put in. And when you put that into your calculator, you get 0.0467. Now, it's a one-tail test. We're comparing it with a 5% level of significance. We have 0.0467, which is less than 5%. This means that we are in the critical region. Okay, so we're in the critical region. This means that there is enough evidence to reject HO, so we can reject the null hypothesis, and we can say that at this significance level, there is evidence to support the complaint. Okay, so there is evidence to support the complaint because we are in the critical region. Okay, so we're going to reject HO. Okay, that's perfect. So that is part B done. Now, the health centre also claims that the time that a dentist spends with a patient during a routine appointment, T minutes, can be modelled by a normal distribution, where T is normally distributed with a mean of 5 and a standard deviation of 3.5. Using the model, find the probability that a routine appointment with the dentist takes less than 2 minutes. So now we have the dental treatment has a normal distribution with a mean of 5 and a standard deviation of 3.5. And we're trying to find out the probability at the time that the dentist spends with a patient is less than 2 minutes. That's quite normal. You just put that into your calculator in the standard way, and that would give us 0.1956. Okay, so that's the first part there of part C. Now this next bit's interesting. It says the second part, it says find, and this is a very common feature of these normal distribution questions. Find the probability that the time that the dentist spends with a patient is less than 2 minutes, given that the time is greater than 0. Now remember, we've said this before, that when we have this conditional probability, the denominator becomes the reduced sample space. So in essence, what we've got here is the probability that the time is less than 2, given that it's greater than 0. That, in the numerator, is the probability of t is less than 2 but greater than 0. But it's over, this becomes our denominator, the probability that t is greater than 0. So you have like when you have conditional probability, the thing you've got to remember is that this becomes the reduced sample space, it becomes the denominator, okay? Now we know from before our answer, well, actually we can just work out between 2 and 0, and that gives us 0.119119. Again, the probability of t is greater than 0. We can just calculate that in the normal way by putting the lower limit as 0 and the upper limit as, say, a really big number. That gives us a probability of 0.923436. And when we work that out, that turns out to be 0.28995. Okay, perfect. So that's our probability that a patient spends less than 2 minutes, a dentist spends less than 2 minutes with a patient, given that they spend greater than 0. The third part of the question then, it says, hence, explain why this normal distribution might not be a good model for t. Well, let's think about this. So if we're basically saying that if the time being greater than 0 has a probability of 0.923, it's kind of suggesting that there is a probability that the time is going to be less than 0. Okay, so the time that the dentist might spend with each individual patient being less than 0 actually has a probability according to this, which makes no sense. So because the probability of t is greater than 0 is 0.923, then that would rather suggest that 1 minus 0.923, in other words, 0.77, is the probability, according to this distribution, that the dentist spends less than no time, which makes no sense. So that is nonsensical, and that's why this model might not be appropriate. Okay, finally, the dentist believes that she cannot complete a routine appointment in less than 2 minutes. She suggests that the health centre should use a refined model, only including values where t is greater than 2. Find the median time for a routine appointment using this new model, giving your answer correct to 1 decimal place. Okay, now this I think is quite tricky. I mean, presumably this is the last question on the stats part of the paper. This is an A-star kind of idea right now. So what we require here is the probability, find the median time. We don't know what it is. So we want to find the probability that the time is greater than some value, which we've yet to find, given that the probability is greater than 2, and that has to equal 0.5. So we're trying to find the median time, given that it needs to be greater than 2, according to the refined model. We need to find the median time, the value of the time, such that the probability of that time, given that it's got to be greater than or equal to 2, is equal to 0.5. because that's where our median is going to be. Because the distribution is symmetrical, the median and the mean are going to be coincidental. They're basically going to be at the same place. So we're going to kind of like expect the median is also going to be there at 0.5 due to the fact that the distribution is symmetrical. So that's what we've got to do. So let's have a look at this then. So we can now say the probability that t is greater than some value t is equal to 0.5 times by the probability that t is greater than 2. Well, that's the same as 0.5 times by 1 minus the probability that t is less than 2. Now that's useful because we've calculated this probability earlier. So we know that the probability that t is less than 2, we found out earlier to be 0.1956. So when we work that out, we're going to end up with, let's have a look at that. So 1 minus 0.1956 is, we want 0.5 times by 0.8044, which is going to give us, that is 0.4022. Now, this is the probability. Let's look at our normal distribution. This that we found here is the probability. So there's our t-value, and that it is greater than. So this 0.4022 is the probability that t is greater than this new time. So we really could do with, well, I mean, it depends on which calculator you're using, but so that we can make it so that it's applicable to everybody. If we do 1 minus that probability, then this probability here is 0.5978. So if we basically do an inverse normal distribution with a mean of whatever it is, a mean of 5 and a standard deviation of 3.5 for the dentist. So we're going to say, remember that our dental distribution is that we have, it's normally distributed with a mean of 5 and a standard deviation of 3.5. So if we do an inverse normal calculation with that mean and that standard deviation on this area, then that's going to give us the value for t that we're after. And when we do that, we find out that that gives us the time is 5.86 minutes, presumably. And that's our final answer. So that was a little bit tricky. I think the thing that was particularly tricky about that is that it required us to form the connection in our minds that the median value corresponded to an area of 0.5. And again, that's due to the symmetry of the normal distribution, and that the mean and the median are both basically occur at the same point under those circumstances. I hope that you found that helpful, and I will see you in the next video.